Good evening to all. Welcome for all the participants. I welcome Professor M.N. Basuraju, who is the principal of the SJRC Degree College, Bangalore. Welcome you, sir.
Thank you, Dr. Maldesh.
Thank you, sir. I requested Professor M.N. Basuraju, sir, to inaugurate this webinar series. Sir, this is the another batch. So usually me and Basuraj sir will be in one or the webinars and the workshops in most of the days. So he's even he is a principal. He is going to spend a lot of time to learn the new things by attending the webinars and workshops and the symposiums and all. And also he is going to conduct the international webinars and the workshops on various subjects. Professor M.N. Basraj sir, so I request you to deliver few words for the people. Here the most of the students and teachers are there from various fields like the electronics, computer science, and civil, and the mechanical, and even BSc and BCA. So most of the students are from the science background, and few also non the science background also. So we are going to start with the basics of the few electronics concepts so that everyone can understand to interface the sensors and actuators for the microcontrollers and to do some the innovative projects. That is our idea. So so I request you to say a few words to the participants and encourage, sir. Thank you.
Thank you, Maldesh. Good evening, Dr. Maldesh, and all the enthusiastic participants. This combined hardware and software electronics workshop and Arduino microcontroller projects is arranged by Dr. Maltesh for the faculty and the students of Karnataka state, even the states outside Karnataka also. Dr. Maltesh is a very dynamic and enthusiastic professor in electronics from JN University. He has immense pleasure in teaching. Dr. Maltesh is trying his level best in creating an awareness in electronics in the general learning category, starting from high school to the college, PG students, and even professors in the other disciplines in the entire state of Karnataka. Till today, he has conducted a number of webinars in electronics projects. Just 1 hour back, we concluded 40 hours webinar on Arduino and Raspberry Pi. Again, it is conducted under the leadership of Dr. Maltesh and Electronics Teachers Association of Bangalore Central and Bangalore University. So just immediately after that, Dr. Maltesh has ventured into another webinar series on Arduino. I welcome earnestly all the participants and very happy to be associated with all of you. I proudly declare this webinar series inaugurated. I wish grand success in all the endeavors of Dr. Maltesh. I wish an enjoyable learning experience to all the participants. Thank you for your cordial invitation, Dr. Maltesh. Thank you, Dr. Maltesh. And thank you, participants.
Thank you, sir. Thank you so much for the encouraging the words for me as well as for the audience. And here, the audience are from, as you said, from across India, from various the states and all those things. Thank you so much. Now, in this the webinar series, or as the name, the title we have given, combine hardware and software. So as all of us know, it is highly impossible to separate the hardware and the software. It is like our body and the soul, what we say. Okay, so without the software, the electronics machine is nothing but the laptop or mobile or the system, what we call, it is useless. And also the software also useless without the hardware, and hardware also is no use without the software. So these are the integral part. Okay, nowadays the technology is going to go a big level uh, in exponential manner, so only because of this technology, especially the electronic science, the computer science. These are going to contribute to the world in the various levels. So we thought to have a kind of workshops which we try to interface the sensors and actuators to the microcontroller. So which are the hardware parts, but to operate these, we write a software, what we call it as the program. Okay, and we're going to see as the teachers. So all of us going to see the various drawbacks in the students. The drawbacks in the sense, it is only the because of they are not looking into the other side, like the electronics people, including us also. So why in the beginning we were not aware of to learn the other things. So we think that so electronics means we have to learn only electronics, computer science means we have to learn only computer science. It is actually the major drawback, especially in the industries. So the computer science people should learn the electronics and vice versa. Okay, because a computer science people will write a program, but will not be able to interface the sensors. And the electronics people will be knowing a lot of electronic devices and all, but not able to combine all those things, and not able to write a program for a system which is combined one, what we call it as a project. So in most of the youngsters, we are going to see these lacking. So whenever they go for the interviews and all, they'll in industry, say for example, the computer science industry requires the computer science person who knows the electronics, and electronics industry look for the electronics person who knows the software, the techniques and all. Hence, so I request all the participants to look into these major issues. uh, Fine. Today, most of you, I think, you know the electronics concepts and the computer science concepts, but the few may not be, especially from mechanical background or the other, the non-electronic and the CS background. I try to explore few things in the electronics concepts. Okay, and in between also, I'll be explaining whenever is the required and all. Fine. And one more thing, uh, I request all of you to join with your name, and your profile picture, because most of the people are not joining with the names, like the Galaxy or the mobile names will be there, or some other things will be there. So I request all of you to join with your name, and the profile picture should be there for the identification. Okay, and request all of you not to share their ID, please, to others. Okay, because it is a continuous the webinar session, and there will be linkage between the one session and other session, and there should not be the gap at all, please. Okay, fine. First, we see the electronics. So, as we know, the electronics is the study of behavior of the electrons. Okay, we have in engineering the various branches are there, but especially electrical engineering and electronics. Okay, both are the branch of engineering. Before, in the beginning, we try to define them as the branch of sciences and later the branch of physics and all. But now they are going to be defined. There's electronics is going to be electronics as well as the electrical engineering going to be defined as the branches of engineering which deals with the study of the um, movement or the study of the electrons in the semiconductors, vacuums, and the gases. So in before uh, the semiconductor was not there, so the size of the vacuum tubes and all the bigger. Hence, the size of the devices, that is electronic devices, uh, were also was also the bigger. Say, for example, the size of computer was like the room size. Okay, but nowadays very compact. It is a palm size, we can say. Say, for example, mobile is a the computer because it has all the parts what a computer has, like the processors, that is the CPU, what we call it as, and the input devices like the keypad or touch screen is there, and the microphone is there, and the output devices will be there, like speaker, or again the screen will be there. Okay, so we can say the mobile is also a computer. Basically, the electronic devices or the systems are can be classified into two types, that is the analog devices and the digital devices. So these analog devices will receive the information in the analog form,
अभी आपने
and
म्यूट है ना, अपना आवाज नहीं
digital and the digital systems will receive the information in the digital form. So we know the analog form or the analog signal is nothing but the signal in a sense, the voltage or the current. Together we call it as a signal in electronics terminology. So the analog signal is continuous with respect to time. You can see the analog signal as the time elapses, the voltage goes on, changing in the sense it may increase or decrease. Okay, or it may be constant also, it doesn't matter. Okay, but in case of the digital, it is having the discrete levels like high voltage and low voltage. So as all of us know, the high voltage and low voltage in the sense the 5 volts and 0 volts. So the this in case of the digital system, there are two logics we usually follow. One is the positive logic and negative logic. And in most of the cases, we use only two levels, as I said, the high voltage and low voltage. These voltage levels may be anything. Say I can use 10 volts and 20 volts, or 5 volts, 6 volts, like this. But the popularly used voltage levels are what? The 5 volts and 0 volts. The 5 volts is the logic 1 and 0 volts is logic 0 in positive logic. If it is reversed, that is negative logic, what we say. Okay, so in positive logic, the higher voltage, that is the 5 volts is going to be considered as the logic 1 and 0 volts is going to be considered as logic 0. In negative logic, exactly reverse, that is 5 volts is 0 and 0 volts is 1. But in most of the cases, we follow only the positive logic. And the voltage levels are what? The 5 volts and 0 volts, as we know. So for a computer, we write the language, the instructions in or the programs in various languages, C, C++, Java, and so on, which are the high level languages, what we call it as. But the computers, which is the electronic machine, will never understand those, the high level languages, but it will understand only the high voltage and low voltage, because the computer or any digital system is made of the logic gates. The logic gates are the building blocks of any digital system or the computer. They will understand only the voltages or the currents. So that is high voltage and low voltage. high voltage is usually 5 volts, and 0 volts is what? The logic 0. It is logic 1 and logic 0. So this ones and zeros is also called as the machine language or the binary language. So we try to write the instructions in the form of zeros and ones. So the computer will understand only zeros and ones, but it is very difficult to remember the combination of the ones and zeros for various applications of a system. So came up with what? The assembly language. In assembly language, we write the instructions in the hexadecimal, like 0A, 5 to something like this. That is called the assembly language, and it is also very difficult to remember. So, one second. Hello. Yeah, I'll check it. Yeah, fine. Please log in. Huh. Yeah, fine. Okay. Sorry. Someone was logging and facing a bit problem, I guess. Okay. This binary language is a bit difficult to remember, so the assembly language. And for that, the mnemonics like English like words move, uh, add, sub, like this, the instructions will be used, but it is also very difficult. So the high level language like the C, C++, and all. In high level language, we can write, say, for example, in C, y equal to x plus z. So it is very easy to understand. But internally, that will be converted into the binary language, which is the combination of, again, zeros and ones. Okay. For this conversion, we have the softwares called compilers and interpreters. Most of you know this. And to convert the assembly language into machine language, that is the assemblers, which are the softwares. Okay, fine. So basically, what I'm going to say, a computer or digital system is going to understand only the high voltage and low voltage, can be represented using zeros and ones. Hence, the binary language is the machine language, or the computer language, what we say. The electronic circuits. The electronic components, like the diodes, transistors, and so on. Most of you have seen the components like resistors, capacitors, and all. So using these combination of these components, we build a circuit for a particular application. Okay. The electronic device, whenever we call electronic devices, it should be made of, as I said in the beginning in the definition, the electronics is the branch of engineering which deals with the study of behavior of electron in the vacuum tube, the gases, or the semiconductor. But nowadays, the vacuum tubes and gas devices will not be used much, but we have the semiconductors. So if you want to call a device as electronic device, it should be made of what? The semiconductors, like diodes, the transistors, and all. Okay, I'm not going to go in detail with all those things. So later, whenever it's required, so I'll try to explain those. So computers, as all of you know, it'll be having the CPU, and it will be having the input devices, the output devices. In the CPU, the control unit will be there. The CU, what we call it as arithmetic and logical unit, that is the ALU, will be there, and the memory unit will be there. Okay, and all these made of most of the components are made of what? The logic gates inside the CPU. Okay, and to connect the input devices and output devices, so there will be the interfacing the ICs or the components like the IO ports. The IO ports, we cannot directly connect the input devices and output devices to the CPU. So we try to connect through the ports, what we call them as the input ports and the output ports. These ports are again the made of what? The gating system like logic gates. what we call them as the flip-flops. The flip-flop is a memory element which is made of the logic gates, okay, which stores a single bit. A flip-flop is a memory element which stores a single bit. If you want to store the 4 bits, we have to use 4 flip-flops. To store 8 bits, 8 flip-flops. So a group of flip-flops is also called as a register. So these computers can be classified as the 4-bit. They'll be having the processors like the 4-bit processors, 8-bit processors, 16-bit processors, and so on. So 4-bit processor, in a sense, the processor which processes the data only 4 bits at a moment. Of course, 8-bit processor will process 8 bits at a moment. In the sense, say for example, if I ask a question, what is 2 plus 3? So it is 5. 25 plus 60. You can add 235 plus 685. So if I goes on, if I go on increase the bits or digits, so it will be a bit difficult to add you immediately. So it doesn't mean that it is not possible, but it is possible. But we go for the digit by digit. Means we take one digit of the first number, second digit of the second number from the. We start from the right side, and we move towards the left side by adding those, including the carry also. Here also the processors will take the, say for example, 4-bit processor. We can write the numbers, the binary numbers or the any numbers in any number of bits or digits. In the same way, in binary numbers also, say for example, 20 bits of one number, another 20 bits of another number. It is not possible to supply all the bits simultaneously for any processor. Hence, we take only 4 bits. Say for example, 4-bit processor will take only the 4 bits of the first number and 4 bits of the second number. It adds those and take the next 4 bits and so on. That is the way they go. In the same way, the 8-bit processor will handle the 8 bits at a particular moment. The capacity will be the double. In the same way, 16-bit processor and 32-bit processor and so on. Okay, fine. Hope you understood the concepts. So most of the students are the engineering and electronics. I think it is not difficult. Just I'm going to summarize for others. There are many, the components are there, the registers, capacitors, inductors and all, but in most of the time, we give more importance for the registers because we will be using the registers in most of the cases, especially in simulation of the circuits in our sessions. So the different registers are there. A register is a component and resistance is the property of opposing the current, flow of the current. Okay, and these registers are made of in the carbon composition. So inside this, the small component, there will be the carbon composition is mixed with the insulating the material. Depending on the composition, it carries the certain resistance. So we try to use these resistors to limit the flow of the current and to vary the voltage. Yeah. To vary the voltage as well as to divide the voltage and all. Say for example, we have a power supply of 10 volts. So I want only the 5 volts or 3 volts. So what I can do, I can connect these resistors in series and we can allow the particular amount of the voltage to drop across a particular resistor and we can use it as supply. Okay, and we can limit the current also. Certain, say for example, to switch on the LEDs and all. So movement of the current also important. The intensity of the LED depends on the amount of the current it flows through it. At the same time, there will be like the LEDs which operate at a particular voltage. So in such cases, we use these the registers. And for example, in live example in our home, to regulate the fan, we use the one knob, that is, it is nothing but a potentiometer. Okay, so as we change the knob, actually we are going to change the resistor. Depending on the resistance value, it allows the current. So does the speed also. And there are different, the symbols symbolically we try to represent in the circuits. Say you can see in the screen, there's a general symbol, the resistor. This is the trimmer. The trimmers are nothing but the very small, uh, the size, the values will be the same, like 1 kilo ohm, 2 kilo ohm, and 10 kilo ohm and all, but the size will be the smaller, so that we try to the solder all these components on a PCB, on a PCB. Okay, and this is the trimmer and potentiometer. The potentiometer is also the variable resistor. It is having three terminals. If you use the extreme two terminals, it acts like a fixed resistor. And if you use the one, the wiper terminal, which is the middle terminal, we can use it as a variable resistor. So we're going to show later in one of the simulating the circuit. That time we'll see. And thermistor, there is also a resistor whose resistance depends on the temperature. So as the temperature increases, the resistance, the decrease, and the vice versa also there. There are like the positive temperature coefficient or the negative temperature coefficient. We have the different the thermistors are there. You'll see. This is a rheostat is also variable. The resistor. It is the photo resistor. So it is like the whose resistance depends on the photo, that is the light dependent resistor, what we call as the LDR. So in this also can be called as a sensor. In most of our projects, we use the sensors. The sensors are nothing but.
Dr. Mal, you have only 1 minute. Ask them to rejoin.
Hello, sir.
You have only 1 minute. Ask
yes. So participants, please, all of you, log in once again because we are using the free version of this Zoom, so it's going to stop at 40 minutes. I request you all of you join once again with the same ID and password, please. Thank you, sir.